I have my own company. It's real small though.
Alrighty, everyone. Good to see you all here. It's nice that you could all make it for yet another one of our amazing meetings. Just in the way of some announcements, we do have a Pancakes and Pontification coming up, not this Saturday, but the next Saturday, October 7th. It will be at the Denny's on Plano Parkway in Preston. Exact address will be sent out in an announcement before then. And so, for anyone who hasn't heard of it, it's a time that we all just go out to Denny's, get some pancakes or whatever else, and just basically talk about any theological topic under the sun. It's a place to bring hard and confusing questions to just have some good discussion over. Tonight's talk is going to be on the fine-tuning argument. Always a good one to talk about. And of course, we have here Allen, who is, this is just your bread and butter. So, so we got a really good talk tonight. So,
all right, yeah, thanks, Sam. Yeah, this is my favorite topic, as a lot of you know if you've been around here for a while. We usually talk about this topic once a year and try to emphasize different things. Last year, we focused on the multiverse, which has gotten all this attention in movies, and just kind of tied it into fine-tuning. This year will be more of the sort of the bread and butter evidence that the universe is finely tuned for life. We'll unpack that just a little bit more. One reason this is an important topic for me personally is that I did go through a period of doubts right about the time many of you were born, probably many years ago. But I did take a while to kind of work through, like, how do I know God exists? What about these smart scientists that don't believe in God? And just had a number of issues. And this was one of the key lines of evidence that really helped me see clearly that the case for God is really pretty overwhelming, and that right there in my own field of study of physics, that there's powerful evidence for a creator. Which, by the way, I'm really glad we have Tim Farage here. He's one of the senior instructors. Some of you might know him for Professor. Okay, great. Even better. So, anyway, I know one time our students mentioned they had someone in their class that started off talking about fine-tuning, in the class, and they're like, wow, they were just blown away. And I'm like, I've got to meet this guy. And so eventually we connected, and over the years we've talked numerous times and so forth. And so Tim he's also sees the evidence for God in nature, sort of intelligent design. So he'll be able to chime in with some intelligent commentary here, I'm sure. But anyway, so that's, as a way of an introduction anyway, that's kind of why this topic is of personal importance to me, and I ended up investing a lot of time to study. I did the book you see there on the right. I had the privilege of co-authoring just one chapter in the book, but it was with this really top expert in fine-tuning. He does it for a living. I have a software company and a physics background. I'm not really doing fine-tuning for a living, but he is. Literally the last 10 years, he's been doing research using grant money and everything on just fine-tuning, and he's cranked out a dozen or more articles in philosophy and physics journals. And he also happens to be a Christian and makes the case for fine-tuning being best explained by God. So he's like a really awesome reference because he's a careful thinker on the subject. And I'll reference him a lot throughout the talk. He's helped me, come up to speed on some of the more detailed aspects of the physics. So, let's start off with a couple of quotes here. One interesting thing about this data is that, unlike in biology, you have a lot of people that will push back if someone makes a claim, for certain things being special in biology and pointing to God. In physics, at least, fine-tuning itself is very widely accepted. So the science that we're appealing to and making an argument for God is not really controversial. Now, the implication, obviously, people are not going to necessarily go along with the argument being successful for God. And that's fine. That's going out maybe in more of the realm of philosophy. But everything that those philosophical arguments for God depend upon from science is pretty non-controversial science, very well accepted science. For example, Stephen Hawking, the now late great atheistic scientist, said our universe and its laws appear to have a design that is both tailor-made to support us, and if we were to exist, leaves little room for alteration. All right, so he wrote this book called The Grand Design, which is an interesting title if you're an atheist writing about the universe, but in which he affirmed basically all the fine-tuning claims you'll see tonight. Now, he did sort of punt to the multiverse to try to explain away, well, maybe we just got lucky. We'll talk to that more later. But similarly, an agnostic scientist, Paul Davis, I understand is how you pronounce his Welsh name, he says the really amazing thing is not that life on Earth is balanced on a knife edge, but the entire universe is balanced on a knife edge and would be total chaos if any of the natural constants were off even slightly. Tim brought a book by Paul Davies that he's read. We happen to be talking about him with Bill Dembski from that recent series. So he's an interesting character because he totally buys into fine tuning, but he's kind of resistant to the God implications, with I don't think having a good reason to be, but we'll see. All right, I wanted to show how this fits into the fact that we are having a series on science, something we often do in the fall semester. We tend to, the rest of the year, focus a lot more on historical arguments, looking at evidence that would be able to affirm Christianity, dealing with objections, evaluating the Bible. But right now, we happen to be in a more science-oriented mode, so if you're not into science and you visited today, stay with us. We have plenty of non-science coming down the road as well. But if you are into science, you're in luck. We have one more week going through a science-related topic. Although this one's kind of interesting. So next week, we're going to have Bo Bishop talk about near-death experiences, which there is actually a scientific peer-reviewed literature of people that supposedly had some kind of experience in a clinically dead state. So it's not, it might not, you see that, you might think, this group has gone crazy. I thought you guys were more grounded, but it actually is a topic that you can look at evidentially. Not every near-death experience claim is something that you can evaluate evidentially, but some are. For example, some people have been considered dead. Their heart stopped beating, their blood was drained, they came back to life, 30 minutes later and described what the doctors were talking about during that, or saw a tennis shoe on the roof of the hospital, or just some really wild things that have been documented. And so Bo has studied a number of these reports that have persuaded non-Christians to think that, oh, there must be something going on here related to near-death experiences. So that should be an interesting week next week. But today we're sticking with a more very foundational, not fringe kind of science at all in terms of fine-tuning. Before we jump into that, I want to just briefly mention, when we raised the question, is the universe an accident? I just came back from a trip to this place right here. I was staying one of the overwater bungalows to the right, and it was just ridiculously beautiful to see nature and how incredible it was. So, interestingly, there's a well-known, have y'all heard of Joe Rogan? He's like a real famous podcaster. He's not a Christian, but he was like a very sort of secular atheistic Jew. But I heard him a while back, like a month or two ago, and he was talking about, he became a theist when he was at Bora Bora. He was looking, seriously, that's what he said is like the turning point for him or something, when he saw the beauty in nature. And we also went to this island, and we swam with, let's see if this comes up, it's not coming up. We swam with whales and manta rays and all kinds of beautiful creatures that, it's going really slow for some reason here, but I don't know if the computer's overloaded.
We can invite the view.
But anyway, let's get it when it's a little closer here. Anyway, we saw some really amazing stuff, and so I think for many people, they look up at the heavens, and if you're in Colorado where you can actually see this Milky Way galaxy, you can be blown away by the beauty in nature. Or if you're at one of many places like this, it does look designed. Even Dawkins says biology is a study of things that have the appearance of having been designed for a purpose. And so Richard Dawkins, this famous atheist, actually issues a challenge that we're going to take up and see if we can respond to, in which he says that the universe that we observe has precisely the properties we should expect if there's at bottom no design, no purpose, no evil, no good, nothing but blind, pitiless indifference. DNA neither knows nor cares, DNA just is and begins to its music. Okay, so does the universe look like there's just nothing special going on? At one level, you can have an argument from Bora Bora that persuaded Joe Rogan or something, but we're going to make it much more quantifiable and mathematical in our approach today. We're going to look at the very most foundational levels of science, which is physics, and we're going to look at whether we can show that the universe actually is special among possibilities. So we're going to take up that challenge. And notice, by the way, that Dawkins just kind of takes for granted DNA. He's not really looking, he's trained in biology, not physics. He's not talking about fine-tuning here, although he admits that he doesn't quite know what to do with fine-tuning in other contexts. But you won't even have something like DNA without an extraordinary amount of special fine-tuning of parameters. So let's define more carefully what we mean by fine-tuning. I like the way that Barnes puts it. In the set of possible physical laws, parameters, and initial conditions, the subset that permit life is very small. And I'm going to throw in intelligent life. If there's a God, it's not unreasonable to think that he might want some kind of intelligent life that he could interact with. And so we can actually evaluate this question by looking at the very most foundational levels of science. Primarily, we can fix the physical laws and look at the constants governing those laws and say, well, what happens if you adjust gravity and make it stronger, weaker, or the electromagnetic force, or particle masses? I think traditionally, until about 50 years ago, people just assumed that probably whatever the values these took on, you probably would have been able to have life in the universe. But physicists have now come to realize that that's spectacularly false. Someone mind maybe closing that door? There's a bit of background noise there. So Luke Barnes, one of his more significant articles was he just did a review article in which he looked at like 200 articles about fine-tuning. Yes, there are that many in the peer-reviewed literature that affirm the kinds of claims we're talking about tonight. And he sort of summarized them in this review article. And really, it's amazing the degree to which you find agreement among physicists. Okay, so notice that if this is true, and I'll give you the background kind of supporting this as we go through this, but notice that if this claim is true, it goes directly against Dawkins' claim. On Dawkins' claim, on naturalism, you might expect, that we just, that you can have any universe come up with life. There's no reason to think that we're that special in our particular universe among possibilities. But it turns out that tiny changes to these laws of nature would just ruin the possibility of life anywhere in the universe. Okay, so if we can show that's true, I think it's very powerfully refutes the kind of Dawkins argument and gives you a strong reason for believing in a creator God. Now, there is also a kind of fine-tuning you'll hear sometimes mentioned that's more of an environmental type fine-tuning, like, oh, the Earth has a special place in the solar system or a special way that it's created. We're not really getting into that here. We're looking at a more fundamental level. Because there are like 10 to the 22nd stars in the universe, and it's harder to make the case like that you might not have some kind of planet that is as special as the Earth for life. There are actually, and I read a book on this on my vacation recently, The Wonder of Water by Dr. Michael Denton, which is kind of interesting, and it gets into the very special nature of water itself and how water's properties play a special role in like plate tectonics and evaporative cooling and transporting things within cells. It's got all these very special properties. It's very unique among liquids in the particular properties it has in terms of its heat capacity, all these different things. We're not even going to get into that. We're going to look at something more fundamentally. But there's a whole host of additional layers of evidence that you could get into. But I think that what we're going to speak to here will be the easiest to defend from the hardened skeptic. And that's why I encourage everyone to think about this evidence, look into it, because it's a very, very good way to approach if you've got or maybe some of you here don't believe in God, and I understand where you're coming from. I've been there before, but I think if you really look hard at this evidence, you'll see that it's a pretty powerful argument. And if you do believe in God, you can take this argument to your unbelieving friend, especially if they have a lot of respect for science, as many of them do. It can really get their attention. So how was this discovered? One interesting thing is that this wasn't discovered by just like a bunch of Christians or Jews or something looking for it in science. It was actually discovered by more atheist or agnostic scientists, again, about 50 years ago or so. And so they weren't really seeking, there was no motivation for them to just latch on, find evidence like this. We're talking about people like Fred Hoyle, Bernard Carr, Barrow and Tipler were very significant. They wrote this book on the right, which is it's got a lot of details, a lot more than I'm going to get to tonight in terms of fine-tuning. And one interesting thing is that when Frank Tipler wrote this book, he was a non-believer. But look at how it impacted him. He said, when I began my career as a cosmologist some 20 years ago, I was a convinced atheist. I never in my wildest dreams imagined that one day I'd be writing a book purporting to show that the central claim of Judeo-Christian theology are in fact true. I've been forced into these conclusions by the inexorable logic of my own special branch of physics. So, yes, this kind of evidence has converted a number of scientists. But obviously not all. There's many other factors going on in choosing a worldview often than just the intellectual side. All right, so here's kind of how we're going to go through things. We're going to go into physics of fine-tuning and then look at, okay, can you make this into an argument for God? What does that look like? And then deal with objections. Any questions so far, though, just on like, okay, what do we mean by fine-tuning? Is that clear enough? Or maybe I went off on too many tangents. Okay, we will proceed on then. All right, so I think a good place to start with fine-tuning is at the very beginning of the universe. So the very first week, Seth gave our illustrious president here, gave a nice shortened talk on the Kalam cosmological argument, which argues from the fact that the universe had a beginning to the fact that you need some kind of transcendent cause that's outside the universe to bring about the entire universe. And I thought he did a good job with that. But sometimes, that might not be persuasive for everyone. There's maybe a little bit of debate of like, okay, the people that are not believers in God are trying very hard to find a way to make it eternal. And there's a long history of failed attempts. So they're really struggling. The evidence really seems to point to very strongly, I think, to there needing to be a beginning. But if you have doubt, I think it's really interesting to look at this. Was there anything special? Again, think about the Dawkins thing. Does it just look like the universe was set up at random or not? Well, it turns out the special conditions in our early universe coming out of the Big Bang were extraordinarily unlikely to have produced anything but a universe so dominated by black holes that no life would be possible. All right? And a Nobel Prize winning physicist, Roger Penrose, he computed sort of the odds against life, or the fine-tuning of our universe more precisely, at 1 in 10 to the power of 10 to the power of 123, a double exponent there, which, by the way, you take the 10 to the 123rd that's on top together first, and then you take 10 to that power. So if you write out the number, you would need more zeros than there are particles in the known universe to write out that number in ordinal notation, where you just have 1 followed by a string of zeros. So that's just mind-boggling level. And interestingly, I mentioned before, sometimes those who don't believe in God want to sort of hold out for a multiverse theory. This theory that there might be other universes, and if you were to vary the constants in those universes, or the initial conditions in this case, then you might just get lucky, and people that are alive can only find themselves in life-limiting universes. There's nothing to really explain, so goes the argument. But here, Penrose himself argues that the multiverse, he says it's worse than useless for explaining this fine-tuning, which is interesting. The reason he says this is that on these kind of multiverse theories, most of them produce small universes, and those are exponentially easier to fine-tune than a big universe such as the one we find ourselves in. So you could look at, a set of possible universes created by these kind of universe generation mechanisms, which we have no evidence for, but are theorized that it's possible. And then you can ask the question, what does a typical observer look like in that set of multiverses? And Penrose says, look, it's nothing like we find ourselves in. Almost all of them would be in a tiny universe, or perhaps even just a so-called Boltzmann brain, which Seth loves. Or it's like a brain popping into existence out of the quantum vacuum or something of that nature. Anyway, the point is, though, that the fact that we find ourselves in this huge universe that requires so much more fine-tuning shows that the multiverse isn't a good substitute for God in this kind of case. It just looks like something was built in to that's set up the universe, set it up in this very special way. Basically, in a nutshell, what you need is particles to be arranged so that they're not just random, which normally, like on quantum mechanics, you would get sort of random distribution of particles in an early universe. They need to be sort of evenly distributed, but not perfectly evenly distributed, because then you would never form galaxies or stars at all. As the universe expanded, everything would just stay totally even if it were perfectly even. So that's why Penrose, he's able to do the math on this and show that it's this level of improbability. Yeah.
So if I could kind of riff on that like it's ultimately unsurprising that we're here, kind of weak anthropic principle
Sure.
rejoinder to it. Just seeing like kind of this idea of exponential degrees of freedom kind of changing things. Could we also deal with a response that would say, well, this universe is just the lowest number of degrees of freedom that we could have, and all the rest of the universes that were going to be more complex, so they were going to be way bigger, they just didn't work. So this is actually small relative to the number of possibilities.
Well, Penrose himself argues that it would have been easy for life to arise in just a single solar system. I think that is pretty persuasive. There's just nothing about having all these extra galaxies that help the origin of life on Earth or the evolution of life if you go along with evolution. Rob?
It's only easy compared to that overwhelming possibility though, right? Because otherwise it's just like life popping up out of nowhere, unguided in a solar system. You'd still have very complex conditions for that.
Yeah, he said that was 1 in 10 to the power of 60 to get a solar system with the right conditions to allow structural formation. So you're still at a level of improbability. Ashton?
I just want to get your opinion on the multiverse answer to the problem of evil. Because the problem of evil from a skeptic point of view is that if God is so good, he wouldn't have created such an evil world. So why can't we just say that there's an infinite number of worlds and this one just happens to be evil?
You're using a multiverse response back on them sort of thing?
Yeah.
That might be a little off topic, but that's an interesting thought.
Yeah.
I think I think we probably, did we talk about problem of evil last year? I'm trying to remember.
No, we haven't in a while.
If we didn't last year, we should this year, because that's a core topic.
Yeah, we
we
really
can't go more than 1 year of skipping on. So I think there's some decent responses to that. Admittedly, I think that is the hardest challenge for me to answer as someone that believes in God. It can be surprising the degree to which there's suffering. A lot of my answer is that people sometimes only find God when they're in a situation in which they are suffering. If you look at testimonies of people that have become Christians, it's often, I was living my own life, I was happy, everything was great, I never considered God, but after this happened, I started realizing I need God. And so once you realize that kind of thing, you're like, well, maybe God doesn't want a universe where everybody's just is living in a bungalow in Bora Bora all the time and having all you can eat food and whatever. Go ahead, what else?
I also wanted to say that I think, we tend to focus on the bad parts of society, not only because the news shows us the bad parts of society, but we just, as humans, focus more on the bad than the
True.
good. So like, even with, that's why grudges exist. You're gonna focus more on the bad of someone than the good of them.
Yeah.
So I guess you could respond to that, well, what about all the good in the world?
True. Yeah. We might be getting a little off topic,
Yeah,
but I'm
right.
glad you brought that up.
Just
I mean, that's a very powerful point as
Sounds
well.
like a pancakes question.
Yeah, we
Yeah,
should,
that's true, it really
we
does.
should go into that. Okay, so back to fine tuning. Okay, this is really interesting. Penrose, he computed the precision of the Big Bang explosion to be greater than that needed to blow up a pile of rubble and obtain a fully formed building complete with desks, tables, chairs, and computers of all things. So yeah, it's hard to wrap your mind around that level of improbability, right? So he came up with this computation to help you see how, if you saw that happen, and we weren't just playing video in reverse, you would think that was some kind of design, right? You'd be like, I can't even picture how someone could blow something up to do that, right? We don't know how you could make that happen. But if we did see that, we'd know that was designed. It's similar degree of fine-tuning in the early universe. All right, so that's the initial condition. That's all we're going to say about that. We could make a case even just from the laws of nature without even getting to the constants of the laws. For example, interestingly, you can write down the lowest level physics of the universe on a sheet of paper, basically, which is itself pretty cool, that we have this elegant design that explains everything we see, and that it's mathematically representable, and that we as humans can understand. If you study your whole life anyway, you can understand a lot of it. But yeah, we basically have four fundamental forces. We have the strong nuclear and the weak nuclear force, electromagnetism, and gravity. And if you were to change the relative strengths of these, you would totally wreck things for life. You might not have structure formation at all. Likewise, if you were to change, some of these have infinite range, like gravity and electromagnetism, and others have a very narrow range. The strong nuclear force, it's great for holding those protons and neutrons together in the nucleus, which would otherwise repel, right? All those positive charges. If strong force wasn't stronger than electromagnetism, nucleuses wouldn't form at all. That's an example of just showing you how easy it is to use theoretical physics to predict what the universe would be like if you start changing force strengths. But if you actually get rid of any of these forces, with the possible exception of the weak force, some people cleverly found a way to argue that you could have life in a universe without the weak force. But to do so, Barnes pointed out, they had to add all this other fine tuning. So everything else became more finely tuned when you got rid of it. So it doesn't really do away with fine tuning. But the main point at this point I just wanted to speak to is that the laws of nature themselves, this is not a real powerful case, because quantifiably there's not as many, we could flip the strengths of forces or the range. There's not that many possibilities, right, of doing that. And it seems like this is the only one that would work well for life. But it's still some evidence, right? It's like, okay, we kind of need the universe had to be set up right at the level of laws. But really the mind-blowing one gets into the constants governing those laws as we unpack that more. Or think about the building blocks. And I think it's interesting to just take a step back and think at a real pragmatic level, which Luke and I kind of did this in the book a little bit, of just asking people to think about what you built with when you were younger in the way of maybe an erector set, Legos, whatever it is. Those things are designed, right, to be able to build as many things as possible out of them, to connect well. But you can't build a human that's conscious, that knows about quantum physics from Legos, right? I mean, there's some limitations there. It's pretty interesting that everything you see is basically protons, neutrons, electrons, and of course photons, is what you're really seeing. That's amazing, right? Like everything, whether we're talking about, I mean, obviously as a Christian, I believe there's also a non-physical component to humans, but speaking for a moment just about the physical components that make up the world, these chairs, carpet, everything about you that's physical, it's all really just those very small number of building blocks, right? And that's just incredible that you can build these really interesting things from so few building blocks. So immediately you might think, well, there is something special about that, right? There's something going on here already, you can see. And in fact, there's some fine-tuning required just to get stability, to have long-lived things that can form structure is much more of a challenge than you might think if you start looking at theoretical physics. For example, you need consistent properties. So, planets can orbit a star at pretty much any distance. If you put them at the right speed and so forth, you can have a stable orbit. But if electrons orbited the nucleus of atoms at just any distance, then that would not be good, because then they wouldn't have consistent properties. As Samantha is nodding her head as a biochemistry graduate. So you actually need quantum mechanics, right? In chemistry, you have to learn about the orbitals and all this stuff. And you might be sick of it, but if you didn't have that, you wouldn't have the kind of stable properties that you need for life. And you wouldn't even have atoms. As Luke Barnes has pointed out, it's well known among physicists that without quantum mechanics, atoms themselves decay in a tiny fraction of a second. So if you somehow got rid of this weird quantum mechanical aspect to nature, all the atoms would obliterate in the blink of an eye. All right, so there's something incredible going on that we even have chemistry. And again, quoting Stephen Hawking, sort of a hostile source here, the summed quark masses, quarks are the constituent particles of protons and neutrons. He says they seem roughly optimized for the existence of the largest number of stable nuclei. All right, so we're very fortunate. You might not like that the periodic table is so big, you have to learn all this stuff, but it actually comes in handy if you want to use an iPhone or something. It goes beyond just life permitting. You want rare earth elements. You ever hear people talking about that? China has all these, they're hoarding all the rare earth elements, and it's like, we need to do more to make sure we have them for technology. So we wouldn't even have those kinds of things if we didn't have these special properties in nature. And again, that's not the kind of thing that an observer selection effect could explain, the very fullness of the periodic table for elements that are not even used by life. Titanium is really awesome if you're building supersonic aircraft or something, but you don't use it in your cells, as far as I know. I'm pretty sure the answer is no. All right, so.
Allen, let's see, where's neodymium there?
Let's see, right there, 60.
Yeah, neodymium is the most magnetic element. And there's probably some, like an electric toothbrush and electric shavers, they have neodymium in it. So it's very important and useful. So much of electronics.
Yeah.
Probably in your cell phone.
Probably. They're fun to play with those magnets too. They're so strong, right? All right, so one of the fine tunings, for example, is that if the strong force is too strong, and we already talked about this one, you could have easily not had anything other than hydrogen, because you couldn't form nuclei if you didn't have something to hold together those protons in the nucleus. So hydrogen only, you're not going to have any life. I can tell you that right now. There's really no chemical reactions. There's no chemistry with just hydrogen. You can form H2 and that's it. If the strong force was just 2% stronger, this is more subtle. You might not be aware of this. Protons wouldn't form from quarks. So that could mess things up pretty easily, right? And you want protons or you don't have even hydrogen. If the neutron mass was 0.2% lighter, all protons would transform into neutrons. And if you have only neutrons, you have no periodic table whatsoever. You have nothing remotely like chemistry, nothing that could form life. A tiny increase in the mass of the up quark and no nuclear atoms would exist. And a tiny increase in the mass of the down quark and you'd have only hydrogen. So there's all these kind of things that have to be just right. The living island that gets these masses right for life is at most 1 in 10 to the 20th power. That's 1 with 20 zeros after it. That's bigger than our ever-growing national debt. Worse than chances of winning Powerball twice in a row, and you could throw in on your birthday. Maybe a little bit less probable. So coming out of the Big Bang, we actually had just a handful of the light elements. So again, this would not have been enough for life. In order to form life, you need to form these other elements in stars. Also interestingly, these were sort of cooked in a nuclear furnace in the early universe over a period of about just 20 minutes. So the universe was extremely dense and hot in the early state, and it was expanding. And if it expanded too fast, you might not have had anything but hydrogen. If it expanded too slow, it might have recollapsed and just been one black hole. So the fact that it was able to expand long enough to give you some of these additional elements was very significant. Especially you want to still have both hydrogen and helium, and it requires fine-tuning to still have both of those. All right, but with stars, we're able to make this incredible variety, although we don't make all of these down here. They're very short-lived, they're made in labs. So in summary, sort of, what could you change without messing up life? Most of the physics that you've ever heard about actually does require significant fine-tuning. Anything that interacts with something that life actually uses or is related to does require a significant amount of fine-tuning. But even things that you might think don't matter, like dark matter, turns out it plays a key role in galaxy formation. And so it allowed us to form galaxies, stars, planets. A lot of that was really dependent on having the right ratio of dark matter to so-called baryonic matter, which is everything else that does sort of reflect light, and you can see in telescopes. Physicists are still struggling to really nail down, well, which particles form dark matter, which is a challenging problem because, again, dark matter is called that because it's not really emitting photons, it's not reflecting light, you can't really get a handle on it very well. Or even things like the masses of neutrinos. There's literally trillions of neutrinos going through your fingernail right now, coming from the sun, even through the Earth, by the way. So even though it's nighttime, they're still coming through the whole Earth to get to you, because they don't interact with matter much, and they're in enormous quantities. So if they had even a tiny mass, that could have really messed things up in terms of long-lived stars, and there's different types of neutrinos. There's a lot of ways, actually, even in just neutrinos, that you could have potentially messed things up for life. But here's an example that I like to speak to that I think helps you see that you do need fine-tuning, and that's stars. So I think we can all see why our sun is important. If you got rid of that, life would die out fairly rapidly on Earth, right? Get colder and colder, we need a photosynthesis, plants, the food chain. It's pretty obvious, right? You need some kind of energy source. You could say, well, it doesn't have to be a star or something, but there's no alternative that we know of for a long-lived energy source. And so I think you can just kind of look at the fine-tuning needed for a star and make a case out of that. So first of all, what is a star? Well, it's basically a controlled nuclear bomb held together by gravity, right? I mean, you've got this fusion going on, a lot of hydrogen going to helium, and depending on the kind of star, you can have all kinds of other nuclear fusion processes. But these release energy, and it turns out they release energy in a relatively slow, controlled manner based on the laws of physics. Now, if you change the laws of physics a little bit, you can totally wreck that, and it could blow up like one of our nuclear bombs, right? When we detonate a nuclear bomb, it's very rapid. Okay, that's not what you want for life, right? It kills life. So what, I think you can kind of see, if you want to have this kind of energy release last, say, billions of years, you're going to need something special to kind of control that balance between gravity, nuclear fusion, energy release, etc. And one of the interesting things actually is to compare the rate of energy release of the sun versus you. Everyone in this room is emitting energy. You're metabolizing, you're a black body emitter just by virtue of having a non-zero temperature. You can compute your energy release rate. You can divide it by your mass, which for me is more than after I went on this recent trip. But, and then you can compare that to the sun. All right, and which releases more energy per kilogram, do you think, you or the sun? Kevin, go ahead.
I am answering.
Oh, you are. You're raising your hand now. You are. Yes. It's actually surprising at first, but your body, by quite a large factor, is actually releasing more energy. The sun's energy release is very much slowed down because of the fine-tuning. It takes actually, I want to say it was like over 1 million years for a photon emitted in the sun's core to make it all the way through the soup, a plasma soup, and to be released from the exterior. But obviously there's an enormous amount of energy released from the sun, but remember, it's enormously bigger than you as well. So when you divide by mass, that's the key factor here. And so if you do the math on this, as several physicists have, you can conservatively say it's fine-tuned to about 1 part in 10 to the 35th power. And so realizing that it's hard for all of us, myself included, to wrap your mind around these kind of big improbabilities, I did some computations. I looked up on Google, how big is a typical grain of sand? I kind of chose a middle size in there. And then I said, okay, let's form a sand pile with 10 to the 35th grains and see how big that is. And so I started with Europe and Asia combined. They're pretty big. Asia is the largest continent by far. How high would that sand pile need to go with that many grains of sand? So it turns out it goes up to the height of the moon. And so you can think about this analogy then of coloring 1 grain of sand red, mixing it in there randomly somehow. I guess you need a spacecraft for that and digging machines, but it's just a thought experiment. You can't even build a sand pile vertically from Eurasia to the moon, but just go with it. You get a visual picture of the number of grains of sand. And so the probability of randomly picking blindfolded 1 sand grain and getting the right one that's red is this comparable to these odds of this fine-tuning. So that should blow your mind. It's pretty improbable. And actually I underestimated. The sand pile in my computations was 5 times larger than that.
What was that fine-tuning of what?
Of long-lived stars, the various fine-tunings related to the masses of quarks and the strength of gravity relative to electromagnetism, some of those things. And if you think, well, wait a minute, I'm not sure I trust you, take it from this atheist physicist who led this Perimeter Institute, a physics institute in Canada for many years, PhD from Harvard. He puts it a little more, less conservatively than I did. I think he is actually going a little bit beyond. He might be looking at the question of containing stars, period. But he says the round number is 1 in 10 to the 229th power. So that would be like doing that red-green experiment 6 times in a row and always getting that red green. Pretty crazy. Now there's actually other things just within the realm of stars that relate to fine-tuning. So Fred Hoyle, the famous sort of agnostic scientist, many years ago, he's the one with the famous quote that he said something to the effect that it looks as though the laws of nature, someone's monkeyed with the laws of nature. There's no blind forces worth speaking about in nature. And primarily this is one of his main reasons for saying this. he discovered that you had to get the nuclear resonances that are involved in allowing both carbon and oxygen to be produced in stars just right. Tiny changes to some very fundamental parameters would have wrecked things for the possibility of having both carbon and oxygen in the universe. So carbon, of course, we understand that's really the basis of all known life, and it's way better suited for life than silicon, although people like to talk about, what about silicon life and all that? And then oxygen is really important for energy harnessing and that kind of a thing. And also it's a constituent, obviously, of water, which I did talk a little bit about the importance of water for life. So the strong force relative to the electromagnetic force, they need to be fine-tuned to within 0.5%. You change the charge of the electron by just 1 in 100 million, it messes us up. And so this is just another example of fine-tuning. By the way, the importance of carbon, just carbon and hydrogen alone, there was a textbook that documented 29,000 plus known chemical compounds involving those two. And I'm sure in organic chemistry, you're having to learn more than you want to know about that kind of thing. All right.
Let me throw some in.
Yeah, please.
So we've got this periodic table, right? If you don't have, carbon is the only element that allows you to form chains. It's nice to think about Star Trek and silicon. You can forget silicon. And then water we're still constantly doing research on water. You know, you mentioned it. There's so many properties of water that are necessary for life. So I don't think any universe anywhere without carbon or water is going to be able to have life. Just those two things. You need more, but without carbon and water, you can forget it.
Very, very well put, yeah. Here's another example that's one of the most solid ones. Sometimes people say, well, what about other life forms? You're not considering enough. This one is incredibly clear cut, because in order for there to be any structure formation at all in the universe, it's widely agreed among physicists that you need this constant called the cosmological constant, finely tuned. Now this relates to the expansion rate of the universe. There is actually, it was discovered in 1998 when they were looking at exploding stars called supernova, that the universe is not just expanding, but it's actually accelerating in its expansion. It's expanding faster today than it was yesterday, and so forth. And that force that's causing it, in contradistinction to gravity, which would pull together matter, is due to this cosmological constant. All right, and so it turns out that you can't have that constant be just anything, or it would really wreck things for life. So it is a very small constant, because if it was any bigger, we would have already expanded so rapidly you wouldn't have structural formation. Luke Barnes himself, he's done peer-reviewed publications along with a team on this particular topic, where they were considering if it was different, you know, evaluating all these different scenarios with supercomputers to see what happens. And so they were able to nail down the level of fine-tuning to about 1 part in 10 to the 90th power. So that's 90 zeros. So this is between 2 and 3 times the sand experiment. Now it could be negative. There are known forces contributing to this based on quantum mechanics within the universe. And there's sort of this miraculous near cancellation that resulted in it being a very tiny, small number. So if it happened to be negative of any value at all, that was, there's known contributions that are 120 orders of magnitude greater than the net value. In other words, 1 with 120 zeros after it. There's a very powerful forces from quantum mechanics that are quantum field theory, to be more precise, that are causing this. But somehow we have this, this cancellation. So here, the relevant example to grapple with the probability is one that's much harder for us to intuit, but think of all the subatomic particles in the universe. If you could mark one, you can't really say you're marking it red because it's a subatomic particle, but the odds of choosing a particular particle from among all subatomic particles is about 1 in 10 to the 90th, by most estimates anyway. So, yeah, the universe is much bigger than we think, and subatomic particles are more numerous than we tend to be able to conceptualize. So that's a really big number. And yeah, this one's really clear cut, because if it was, Barnes has done the computations on this and the theoretical work as well, and others have affirmed it, you would end up with basically nothing more complicated in terms of the structure than a single proton, which is a hydrogen atom, and it would be separated by distances greater than the size of our universe, basically. So if you can envision a life that could exist as a single hydrogen atom with nothing else, then more power to you, but that doesn't seem like a viable candidate for life. So that one's really clear cut and also very extreme in its measurement. Now, one last thing on the physics of fine tuning. We've kind of beat that dead horse by just giving, I think, a few key examples, but there's also this interesting concept of sort of a higher order fine tuning. It turns out that a single constant, say the strength of electromagnetism, it turns out to be just right for a large number of independent life-permitting criteria, such as long-lived stars, atomic stability, protons being stable and not decaying into neutrons, for example, or the production of carbon and oxygen in stars, or that the energy output by stars just happens to be harnessable by chemistry. If it was all in, X-rays, it would be just ripping apart chemicals. You wouldn't be able to have photosynthesis. Or if it was not energetic enough, it wouldn't be able to be harnessable either. So there's a large number of these coincidences that all relate to a single parameter. There's others I won't even get into. Sometimes, too, it's based on a linear constraint on one of these life-permitting criteria, and another one is like a quadratic. So it's really interesting that we even have any simultaneous solution to all these equations to allow life-permitting constants. So yeah, if you kind of think about these life-permitting criteria being these arrows, the width of which relates to the range for that life-permitting criteria. Some of them are more narrow than others, but the value in our universe intersects all of these. If there was just one life-permitting criteria that it didn't intersect, no life anywhere. So this is the actual picture. And so again, that looks like the kind of thing that would be difficult for a multiverse, you just got lucky kind of explanation to account for. Seth?
Yeah, no, I was just gonna ask you about that, just to like make that clear, that the multiverse would just move that red line, right? It wouldn't adjust the yellow arrows.
That's a good way of putting it. He is a physics major, by the way, Seth. So, okay, yeah, exactly. I should say that as I'm going through that slide. So by summary, we have finely tuned initial conditions, particle masses, fourth strengths, cosmological parameters, and the consensus among physicists who've studied this is that nearly all choices for the values of these fundamental parameters would lead to a lifeless universe. Not just, evolution could have done things differently. They have very generous expectations of what evolution could and couldn't do, and they're saying, no, you wouldn't have life because you'd never get evolution off the ground, you wouldn't have structures, things like that. We're just looking at clear-cut cases and saying that, yeah, you need fine-tuning to avoid clear-cut disasters for life. And the fact that this understanding is based on our most foundational understandings of science, I think is very significant. It's not likely that we're going to make some new discovery and all of a sudden all the fine-tuning is going away. For example, when we discovered that quarks made up protons and neutrons, they weren't fundamental particles, all that did was shift the fine-tuning up a level and had no net effect on the level of fine-tuning. So really, there's no deeper theory demanding the particular values, such as the strength of gravity or electromagnetism or particle masses. We just go, as physicists, we go do experiments to determine what those are, and that's it. There's nothing driving it that we know of for everything that we've discussed here. A really good book on this is called A Fortunate Universe. It's by Luke Barnes, co-authored with Geraint Lewis, who's an atheist. They agreed on all the physics in the first 6 chapters. And then in the 7th, they kind of each give their spiel, where Barnes argues for God as the best explanation of the fine-tuning, and Geraint Lewis argues for the multiverse. Again, not by appealing to any empirical data at all, but just the possibilities. But there's, as you can see, there's a number I didn't mention, and that you can find top physicists with PhDs from Cambridge University discussing this in a book that was sort of approved or recommended by a Nobel Prize winning physicist, Brian Schmidt. All right, so any questions about the physics of fine-tuning so far? How are we doing on time? I just realized I don't have my phone out here.
It's
8:03.
8:03.
Got plenty of time.
Okay, good. Any questions about physics? Maybe I'll get my phone out so I can guide the rest of this.
I want to make a comment about something.
Please, yeah.
All the heavier elements, basically lithium and beyond, that we require, came from explosions of supernova. So you've got to have a universe where a supernova can form, and it's going to be very low probability of that. And then you have to be close to it, and so these supernova create all the elements except for the first few. And it takes a lot, all this stuff has to be fine-tuned in order to ask. You got a comment on it?
Yeah, I was just gonna add, you need to have enough supernova in order to get those heavier elements out of there, but you wouldn't want to have too many, because each one of those, each supernova sterilizes a region of space around it. So if that was happening more often than it is, it would make the universe less life permitting in general. I mean, I know like the center of the galaxy is usually thought to not be as life permitting, given how many stars are super close together and how many supernovas are going off.
Yeah, but excellent points by both of you, yeah, that I didn't even mention. Yeah, even with the stellar fusion to form carbon and oxygen, they'd be just locked in the stars unless you had a way of distributing out there. The first generation stars are thought to have been what they call metal poor, and you needed multiple generations of accruing these elements. You needed a way to distribute them and then have the planets form from them and so forth. And you could say, well, God could have done it other ways. Is this really evidence? But the whole point is you want to look at, what do you expect on naturalism? Nothing special, just randomly selected constants from among possibilities. Is it really likely that there would have been a life-permitting universe at all on naturalism? It seems not. On theism, even if you have some questions like, well, God could have done it all these different ways, and maybe he did intervene and create our planet specially. I don't know. I know that physics has a way to do it that could have been done as well. It almost doesn't matter. The whole point is theism, the belief that there is a God, creator God, designer, versus atheism or naturalism, that nature is all there is. In that comparison, you can do the math and show that this is very strong evidence for the need for some kind of designer, creator. Even if you have questions about, like, well, why did he do it that way? And it seems improbable compared to, you're up against these incredible odds. Even if you think it's 1 in a billion that God would have wanted a finely tuned universe or would have done it this way, it doesn't matter. It's up against 10 to the 90th and things like that. Ashton.
Yeah, so like Penrose says that the fine tuning, the multiverse hypothesis is worse than useless. I was just wondering, like, how would you respond to the atheistic objection that God as an explanation is also just as ad hoc and contrived?
Okay, yeah, we have that more in section 4 there.
Okay.
So maybe we'll mostly defer to that. I think here you could say, you could do this as a Bayesian argument, or I'm in a minute, well, actually even in section 3, we'll get into how do you go from this data to an argument for God. There's multiple ways to formulate it that I think all work and have maybe pros and cons, but maybe we need to do that before we even respond to that. All right, so let's jump into that. this is sort of the easiest to understand argument. If you set it up, this is sort of how William Lane Craig does it as a deductive argument. So you could say that fine-tuning is due to either necessity, chance, or design. And really by design, I think you could say that, well, I think I've got a sub-bullet later on this. Yeah. Okay, if it's not designed, the only alternative is some combination of necessity and chance. By necessity, we might say, well, the laws of physics had to be that way or something like that. And by chance, you could say maybe we just got lucky in the parameter settings, which, by the way, at least for like the weak force, there's thought to have been something that happened in the early universe that affected the value that drove that strength to. So there's something even within physics where it might be that you've got some way of setting the constants, which is important. But just focusing on this argument then, it's got to be due to design or non-design. If it's non-design, it's some kind of chance, necessity, combination, or all of one or the other. And so if you can show that there's really nothing in physics that's driving the constants to have the specific values, which basically everything we know about current physics is consistent with that. And then you can say, well, look, we've already shown these levels of improbabilities are so vast that chance is a really lousy explanation to rely on. Then you've got a pretty good argument for some kind of designer of the laws of physics. And then this is at such a foundational level, it's hard to envision that being like an alien, right? Because you need fine-tuning before you have life, and you need some kind of divine mind or something to set up physics in order to have life. So I think you've got a powerful argument for, some kind of God. Admittedly, you don't get the Christian God. We've got a lot of other arguments and evidence in our group that we deal with, and I think gives you specificity in that sense. But at this point, this is, I think, is a powerful refutation of atheism, in my view anyway, and we can talk about how well you guys think this works. But does the structure of this argument sort of make sense? I think there's a way of running it as sort of a Bayesian probabilistic argument that's probably a little bit better, but harder to get into the details on. But I think you can sort of see the structure of this just from that. So I think that's how you get to an argument for God. And as a deductive argument for a supreme designer, it's not ad hoc at all. I mean, it's like you've eliminated necessity and chance. The only other thing is design. And so it's not like I got out of the gaps. You're not appealing to ignorance, arguing from ignorance. It's just sort of a deductive argument based on what we've learned in physics. I mean, people were not making this argument 60 years ago or something. It's relatively recent. Once we learned about the physics of fine-tuning, people recognize this seems to have implications. Some people push strongly against that, and they're trying to find ways around it. And we can have those conversations, and we can admit it's not a proof in the mathematical sense, but it's, I think, strong evidence. Was there a hand back there, Rob?
Yes, I was going to bring up the possibility of, well, one potential counter-argument being, even if the chance is negligible, they can still see that, the probability of chance, even if it's negligible, they can still see that as being more probable than a creator. For example, if someone holds to a very strict view of materialism.
Yeah. And in some sense, I mean, I'm fine admitting that. I mean, if you multiply together the improbabilities 10 to the 90th, especially if you can use Penrose's 1 in 10 to the 10 to the 123, which dwarfs all the other ones basically, then, I mean, you've increased, using sort of math, Bayesian probability theory, whatever improbability they thought God was, they've made it that much more probable that God exists. They could always say, well, my a priori for believing in God was 0 or some tiny fraction that makes it still less than half a chance that it's rational to believe in God. I think it should get their attention that I don't know how they could be so sure as overcoming this level of improbability, but I'd be content just to say this should boost your consideration of evidence for God. You can show mathematically strong evidence that should push them in the right direction. And you know, that's the best you can do with any argument, I would say. We could speak briefly more about this question. Could the fundamental constants of physics have been different? So there's a couple of interesting quotes. One is from, again, Paul Davis. He thinks it's demonstrably wrong. There's not a shred of evidence the universe is logically necessary. Like a way to defeat this is if there was some kind of logical necessity to the values the constants took on, then you couldn't really say that it was rigged or improbable in any sense. But yeah, there's really no theoretical physicist that I know of that really goes that direction. What should get your attention? He says, indeed, as a theoretical physicist, I found it rather easy to imagine alternative universes that are logically consistent and therefore equal contenders to reality. No one has ever gone into the back room and used math and philosophy to predict the mass of the electron or something like that. If they ever do, you know, we could revisit some of this, but we're really dealing with things that don't have any kind of logical necessity. One of the people writing fine-tuning articles is Nobel Prize winner Frank Wilczek from MIT. He says it's logically possible that the parameters uniquely determined by abstract theoretical principles just happen to exhibit all the apparent fine-tunings required to produce, but by a lucky coincidence, the universe containing complex condensed structures. But that, by a lucky coincidence, but that I think strains credulity. So if you look at what the physicists are saying about this, they don't see any kind of logical necessity. These parameters could have been different. And in fact, all the multiverse theorists are hoping they're different. They're hoping there's a way to produce universes with different values. So the fact that they're even considering that shows that there's no kind of logical mandate for the values they have. All right, so we could spend the remaining time, and I realize that I think I left my phone in the car today. How are we on time right now?
8:15.
Okay, so let's go into objections, and let me just open it up to any that you guys have. I've got 50 slides just on objections I built up over the years. So I was not planning on going over all of them anyway, but what do you think might be a stumbling block in this as a good argument for God? Any thoughts on any of that? Yeah.
Well, I guess the multiverse argument, at least my understanding of it, is that if there's an infinite number of multiverses, then the probability that you're going to have one which sustains life is always one, I guess.
Yeah. Yeah, I mean, I think that is a good one to talk through. And I do have some. I have a lot.
How'd you go right
just
to
on
it?
that.
Yeah.
Because in fact, last year I did that talk on that, but
Use the you.
Wait,
Let's
Allen,
see.
can you post these?
yeah, absolutely.
Yeah, honestly.
This would be awesome.
I guess let's start, right here. I mean, this is the main response from physicists. A lot of philosophers, interestingly, they don't like the multiverse, right? It does seem sort of ad hoc to them. We have no evidence. It seems like a desperate, so there's not many that want to go there. But among physicists that have studied it, at least, they seem to see that it's like the only alternative if you don't want a creator. So here's some of the challenges. Like, I agree, if you have a certain multiverse, there's at least a possibility that it could give you an explanation for life-permitting universe apart from God. It's just, you really have to admit there's all these things that have to be true before it even meets that level. So you need this huge, sorry for the spelling there, numbers of other universes. Because you got to have more than 10 to the 90, right? Or if Penrose is right, more than 10 to the 10 to the 123. We're not just talking about a few trillion, we're not talking about the number of stars in our universe, things like that. You're talking about much larger numbers of these other universes. All right. And then you have to admit that no one has really even claiming among physicists that we've never detected another universe out there. And on the leading multiverse theory, it's impossible in principle, which is interesting itself. It's called the eternal inflation theory. even if you have these universes, okay, let's say I bought a bunch of lottery tickets and then I told you, I picked my lucky number on all of them. You think that's really dumb, right? You're trying to maximize your chances of winning. Similarly, if you had all these universes, but they all have the same exact constants and laws, that doesn't help you with the fine-tuning of the constants. It might help you with the initial conditions, assuming that could vary. So you also need this independent aspect of the ability to vary the constants. And they can't just vary a little bit, right? They need to widely vary. So people have come up with, you've probably heard of string theory. It used to be more popular than it is of late because, again, no empirical confirmation. It seemed to be overhyped within physics. They spent a lot of money on it, and they came up with some great math, and even won a Fields Medal in math for it, but they haven't yet shown any connection to the real world at this point. But it's thought that if string theory was true, it might give you the ability to vary the values of constants. But that's independent of having multiple universes. You need both. But not all string theory versions would allow you sufficient variance of those constants. But people have sort of latched on to one. By the way, I don't have the sound going here, and we're short on time anyway, but here's where Penrose, he says string theory or so-called M theory. It's not even a theory, it's more of a collection of hopes, and he really sort of disses it, it puts it in its place. So whatever you end up with in your multiverse theory, though, you can look at the question of, does it make predictions about universes with observers that match, does ours seem typical among universes with observers? And a key problem is that generally for these multiverse theories, the answer is no, for the leading ones in particular. And that's why Penrose said that multiverse was worse than useless. And we kind of talked through that. Didn't talk about that other thing, so I'll skip that. But when you have fine-tuning beyond typicality, like as I was going through it, I filtered in a few ideas, such as Hawking saying, you've got optimized, the periodic table for the number of elements goes beyond what life needs. So there's no observer selection effect that's going to give you, the kinds of things you need for iPhones and things like that. Frank Wilczek says the proton, he looks at these grand unified field theory predictions, and he says within those, they have protons that would decay in ways that would mess up life generally. But so far we haven't, at least I haven't heard of it. If it happened in the last few years, we still haven't detected actual proton decay. So the proton lifetime is really long-lived, and that's way more than you would expect on these multiverse theories. The fine-tuning of things like water is far more special than is necessary for life. So we talked briefly about that. Didn't know I had that integrated in there. There's just a whole lot that could be said about this whole level. And in particular, one of the interesting things, if you look at peer-reviewed articles by some of these multiverse advocates, such as Lincoln, he's also appealing, in order to overcome the improbabilities of getting universes, he's appealing to something called the many worlds interpretation of quantum mechanics, which is not very well received necessarily within the broader community. It's very speculative. But in this peer-reviewed article one time, for example, Lincoln said that on his theory, there are infinitely many regions where Al Gore is president, and yes, Elvis is still alive. So they used to make fun of like Christians, right? If you guys believe in all this crazy stuff. And then literally now they're saying they've got this theory where there's pink unicorns all over the universe and things like that with no evidence for it. And they're trying to go that route instead of theism. But the biggest problem, I think, is the observers it produces are of the wrong type. You could end up getting these Boltzmann brains, this brain coming into existence. Don Page is a prominent cosmologist, said any vacuum capable of supporting observers eternally inflates. That's the leading multiverse theory. Such a vacuum produces an infinite number of these Boltzmann brains. This would be an unembodied mind, or it would be a mind that just pops into being, not through some long process of living on a planet and everything, but just out of this quantum vacuum. And we all know we're not Boltzmann brains, right? We know we have a history, we haven't been here for a fraction of a second. And so if your theory is predicting something that doesn't match what we know in reality, then it's a pretty good reason, I think, for rejecting that theory. What do you want to add to that, Seth?
I was actually just going to ask a question. It's probably pretty high level, but
Okay, good.
I just wanted to say, you said that the any vacuum supporting observers internally inflates. In internal inflation, which vacuum are we talking about? Is this the still expanding vacuum that's collapsed from the inflaton field, or is this the expanded inflaton field in between the bubble universes?
It's just in general, just that you have this expanding inflaton field producing these bubble universes.
Okay, and it's
eternally,
more of those are going to be vacuums that just brains pop up in.
Yeah, and by the way, and not every version of inflation produces that kind of eternal inflation either. It's only one particular kind that, again, we don't even know what would cause inflation, if anything. Not all cosmologists even believe in inflation, but it may well be something that happened early in our universe. It's pretty reasonable to think that it did, but it doesn't necessarily mean that it was of the kind that would produce other universes. What would you add to that, Tim?
I just learned this in the last year. It's a little mathematical. How many of you are familiar with the fact that there are some infinities are bigger than others? You heard that?
A bigger class.
That proof is my favorite proof in all of mathematics. It's a little over 100 years old. Anyway, they talk about an infinite number of universes. It's got to be the lowest order of infinity, like the natural numbers 1, 2, 3, 4, 5. So you can have subsets of that. Like if you take even numbers, that's infinite set, right? That's a subset of natural numbers. You can take the multiples of 10. There's an infinite number of subsets of the natural numbers that are all different. But you can define them like I just said, multiples of 2, multiples of 3, multiples of 4. There you have an infinite number of subsets. But there's still other subsets that aren't there. So just because you have an infinite number of universes doesn't mean you have a universe for every possibility. And as a matter, that's without going into quantum mechanics. So because of that, we can only, even if this is true, you can only have a countably infinite number of universes. And it's not going to account for hardly anything here. That was just in the last year talk with. Had you heard that in physics before? It's interesting, isn't it?
I've actually never quite thought of that, but
I didn't either until you.
Cantor's diagonalization.
but
Diagonalization.
I would say though the region where life can exist is still a region of possible values. It's not just one single real number. So wouldn't that not be countably or uncountably infinite if we're taking regions, because that would be subsets of infinity that would actually work for life instead of a single real number.
I'm talking about the number of universes. Even if there's an infinite number of universes, they're coming into existence, and it's got to be a countably infinite number of universes.
Well, yeah, but I'm just saying that it seems like the number of possibilities that would include life would also be countably infinite, or like the number of possibilities it would have to sort through before it hit a life-permitting universe would seem to also be countably infinite and not uncountably.
It's interesting area of discussion. I would argue that we have good reasons for thinking that we don't have an infinite number of universes because we have a beginning to all of them. Lincoln himself, one of the most speculative multiverse advocates, he came up with this Bordet-Lincoln-Guth theorem that Seth briefly mentioned the first week, but he says that the whole multiverse has to have a beginning to space-time. So even if you have this process of producing universes very rapidly, it's not going to be infinite over a finite period of time because it can't do an infinite number at once. So it's a finite number, finite rate over a finite amount of time. So you don't actually, I think, even have, they speak about it. I think Blinken even recognizes it's not really infinite. It's infinite to the future, but it's not an actual infinite yet, is one way to think of it. What would you add to that?
Yeah, I was actually gonna mention that, but I wanted to add on to it that, well, God would have to exist to create these multiverses because God is outside space-time and matter, so.
You still have the
He's
Kalam
he's
argument, you could
outside the
say,
universe.
independently of this, but yeah, there is, it's worth talking through. There's at least ways of minimizing this argument. If you can really give evidence in another universe and a universe generating mechanism that itself didn't need to be fine-tuned. I mean, if you got some way of cranking out all these universes, most ways of doing that probably wouldn't work that well. So that itself seems to also need fine-tuning. We're almost out of time here. We probably beat the multiverse horse to death enough, hopefully, but I'm happy to talk later about that. But is there one or two more quick kind of popular level objections that anybody might want to talk about before we, yes?
So going in the exact opposite direction, because the multiverse stuff isn't really convincing argumentatively, because we only have one universe that we can observe and we know for a fact exists.
Yeah. Okay.
So off of that, I would argue that, like, analogous to kind of like your building exploding, right? And
Right.
forming the complete structure with computers and everything, as you said. If you were to witness that firsthand, just one random day as you're walking down the street, first time you've ever seen a building explode and it happens, if
Yeah.
you saw that, you'd be like, oh my gosh, a miracle just happened. That was like, someone definitely did that, something definitely did that. But if you were to witness the 10 to the 90th times where a building exploded and that didn't happen, that one time you did see it happen, you would just be like, oh, it was just the natural process. This was the one time that it happened naturally. So I think, for me at least, the fine-tuning argument, is that what you call it?
Sure, yeah.
Sure.
When you're making it into an argument for God, yeah.
Right, is that unless we have more universes to explore and see if those are also finely tuned, or if those, result in the building exploding into a tower perfectly built, then it's just not going to be very convincing.
Okay.
If I could add on that, how do you take the step from, we have these observations of ranges to this probability distribution, which I think is similar to what you were highlighting. How do we know what this probability distribution is, or how can we go forward with that?
Yeah, it might seem bothersome at first that we don't, we only have one universe we're observing. How can you go from that to any kind of probability claim? But really it's based on sort of theoretical physics, the whole way that we're assessing it, just like we're looking at the proton, neutron, electron. We know that, or the nucleus being proton, we know with the strong force, I've got too many of these to filter through, but we don't have to go to a universe in which the strong force is less strong than electromagnetism to know that those nuclei would not be stable. It's more of a theoretical physics. So really, the basis of this is more by theoretical analysis. It's, as Luke Barnes says, fine-tuning, it's not just like theoretical physics, it is theoretical physics. You're looking at ways the universe could have been, and then asking the question, how does that affect life in this case? And the overwhelming consensus among physicists is that, the vast majority of ways that we know that you can change it would make it completely lifeless. There's not much of a debate concerning that. Does that help at all, or is that still just seem not persuasive?
Went over my head a little bit.
Okay, that's fair enough.
Sorry.
I don't know if I'm misunderstanding your question, but your question is even if the probability of a universe sustaining life is astronomically low, it's not non-zero?
Yeah, essentially, right? And because of that, and we don't witness all the events
Or
in which
radiation.
nothing happened, right? Then the time we see it happen, we're naturally going to be like, oh, obviously this has a purpose, right? The analogy I like to use, a better one than buildings exploding, is like if I dealt out 5 cards, right, and I gave myself a royal flush, you'd be like, oh, you cheated, right? You'd be like, oh, you're bottom dealing or whatever. But if I dealt you just 5 random cards and it was 5 random cards, that's equally as likely, right? But because we don't assign meaning to it, right? Because it's just a junk hand, you know, we don't really care.
I like that analogy, actually. I think that could be helpful to think through. So yeah, like if we were playing poker and every time I dealt myself a royal flush, would that be evidence for cheating?
I
or
think
not?
it'd be pretty good evidence.
It would, right? Yeah, you
I
probably would
think
not
it
want to
would.
play cards with me again, right? Because it's true that a royal flush is just as likely as any other hand, but that's only true if you're dealing fairly, right? So the improbability of the situation, I think, does warrant a sort of a design or rigging or cheating inference in this case. I think it's similar with the fine tuning with respect to, you know, there's something special going on. We just have one, in this case, you know, we just had one hand, but it's so improbable that it's literally more improbable than me getting, you know, 5 or 10 or however many royal flushes in a row. So it's similar in that regard to the level of improbability. Did you want to add to that?
Maybe just as a little corollary, you know, yes, a royal flush is just as likely as any other hand, but also the analogy doesn't hold exactly because you can still play poker with other hands. Like if getting a royal flush were the only hand that would allow you to play the game, then maybe that would be a little bit closer to the kind of thing that Allen was talking about, where it's just to allow anything else to happen as a result of it is impressively surprising on its own.
There's also a well-known, I mean, this whole thing there's a whole, and that's one of the things I love about this argument as well, is there's a lot of interesting things like that where you can push back and really think through it. There's a philosopher named John Leslie that first came up with an interesting analogy that some people have found helpful, where, you know, he does point out there can be this sort of, it ties into this kind of observer selection effect, or he asks you to think about if you were put before a firing squad, and let's say there's like 100 trained marksmen aiming at you, they all fire and they miss. So you're rightly, I mean, you don't ask like, okay, well, there's nothing to be explained here because if they had not missed, I wouldn't be here. You don't just sort of write it off. The improbability of the situation itself, I think, can help you see that, hey, there might be something rigged here. If they were really aiming for me and not firing blanks, they probably all wouldn't have missed.
So are you saying that the fine-tuning argument is a probabilistic argument? It's not axiomatic or proof?
I think it's best expressed absolutely as probabilistic. I mean, at best, you have these improbabilities. And yeah, you can always say, you could have just gotten lucky with this one universe. But I think if you look at it carefully with the kind of Bayesian analysis, you really can show that it increases the probability of theism relative to naturalism by the amount of the fine-tuning minus some minor potential subtractors, if you think that it's surprising the way God did it or something on this in this universe.
There's something that, were you here for Bill Dembski's talk 2 weeks ago? So he does something interesting called the universal probabilistic bound. And that's for, I think it's getting to what you're saying, you know, you have these certain probability distributions. Basically what he does is, he says from the beginning of your universe till now, and you break it down into Planck time, which is tiny slices, and the size of the universe, and he calculates the number of events, which is about 10 to the 150. So any event which has a probability of less than 1 in 10 to the 150 is very unlikely to occur in the universe. So with some of these probabilities, they're way, way less.
So yeah, you could argue, well, what if there's all these other, you know, what if there's a ton of these firing squads going on? Eventually, they all would miss. But there you could look at, how did they miss? You know, what is the pattern? If they were really aiming, you could actually do some kind of statistical representation if you knew how good a marksman they were. They would tend to barely miss if they were really aiming. But if all of them, hit something 5 feet away, it would look like, oh, they moved their guns over because they didn't want to kill you. And similarly, I think if you look at surprising aspects of our universe that go beyond typicality, you end up with similar reasons for thinking the multiverse, even if there was a multiverse, is still not as good as an explanation as theism for fine-tuning. So we're probably out of time at this point, but this was good discussion. I'm happy to hang around, or I'm planning to go out to eat with the group tonight. We can talk more. For anyone that's interested, where you want to announce that?
Yeah, we're going to be going to Whataburger tonight. It's going to be the one right by Steak and Shake from last week. So that's on Coit, I believe. Yeah, I believe it's on Coit, like just north of Campbell. So
I think it's like right by Walmart.
yeah, the address will be posted in the community meetup page. So yeah.
Great. All right. Well, hope you guys can come, but I'll be around for a little bit more, even if you're not coming and you want to discuss anything else. Thanks for coming. Come next week for the near-death experiences.